Hi, algebra class. So this is a review video for the investigations 1 and 2. And investigations 1 and 2 were about the areas of rectangles and how we can use those rectangular models to help us figure out expanded form and factored form. And we also learned about the FOIL method, and we started the beginnings of factoring. So I just chose a handful of examples that we can go over for those two sections and for the upcoming test. So like all the other review videos, I would say pause the video, work the problem out on your own, and then go back and watch it and see if you guys are on target, then great, move on. If not, go back and listen to my explanation. So let's start for this first one. It says find two expressions for the figure below, factored form and expanded form. So here we are, we have our rectangular model, and we know how to find the rest of the pieces. So let's go ahead and do that. So we know that they gave us that this square is x, the length is x. So we know that there's 3 up here. When we count these, we know that there's 6 here, okay? And now we can go ahead and fill in the rest of the model. We know the area of this square right here is just going to give us x squared. And using that same idea, we can find that this area of this smaller green rectangle is going to be 3x, because we have our length here and we have our width, which is x right here. And similarly for this sixth one, for the bigger green rectangle with a length of 6, we know it's going to be 6x. And then if we go ahead and look right here at our yellow squares, we know that this is going to be 3 times 6, or 18. So now what we want to do is, like the directions asked, it says find two expressions for the figure below, factored form and expanded form. So we know that our first form is going to be the length and the width of the big figure. So here's our width and here's our length. So we have x plus 3 and x plus 6. So we should be pretty comfortable with that. And now for the second way, our expanded form, we want to add up all of the areas that we found of all the little areas to equal the big square. So let's go ahead and do that. So as you can see, we have our x squared plus 3x plus 6x plus 18, which will give us, when we combine our like terms, x squared plus 9x plus 18. But we want to start getting in the habit of rating the solutions because they're equivalent to each other. We want to show that they're equal. So we have the quantity x plus 3, x plus 6 is equal to x squared plus 9x plus 18. So we want to get in the habit of rating our solutions like this. So let's go on to the next one. The next one's pretty similar. It says find two expressions for the figure below, and factored form and expanded form again. So we're given that we have, it's a little bit different this time since we have a square here and then we have another square right next to it. So let's start and fill in the rest of the information. So down here we have 1, 2, 3, 4, 5, 6. We have 6 again down at the bottom, and it looks like we have 2 on this side. So now, knowing that information, let's go ahead and solve for our areas. We know that this first red square is going to have an area of x squared, and we know this second square is going to have an area of x squared. And if we continue across the bottom, we know that this is going to give us an area of 6x, since we're finding the area of this green rectangle. And then I'd want to just point it out to your attention that we have a square, or we have a rectangle here, and then we have another rectangle right here. Okay, so we have 2 rectangles. So for this first one, the area is going to be 2x, and the area for this rectangle up here is going to be 2x. And then right here, the remaining little yellow rectangle we know is going to have an area of 2 times 6, or 12. Okay, so now that we found all the parts, what we want to do is we want to find our factored form and our expanded form. And those two forms, we know how to rate them. Our first form, let's rate as the length and the width of our rectangle. So we have x plus 2 and 2x plus 6. Okay, many of you might look at this and say, where is this 2x coming from? But let me have your attention up here. This is really like a 1x and this is a 1x. So it's not going to be x squared down here. We're going to have 1x plus 1x, and that's where we're getting our 2x. And then we have our 6. And so now our second step is we want to find our expanded form. Basically, what we're doing is adding up all of the areas of all the little figures within our bigger rectangle to find the area. So when we start adding them up, we should have x squared plus x squared, which is the two areas of the red squares, 2x plus 2x, which were our two rectangles up here, plus 6x, which was the longer green rectangle, and plus 12, which were our yellow squares. So now all it is combining like terms. So we should see that our x's, our x squareds are going to give us 2x squared, and we have a 2x, a 2x, and a 6x. 2x plus 2x will give us 4x, 4x plus 6x is 10x, and then we carry down our constant 12. So our final answer should be 2x squared plus 10x plus 12 for our expanded form. But like I said, we want to get in the habit of writing these two expressions equivalent to each other. So we have the two binomials, x plus 2 and 2x plus 6 is equal to 2x squared plus 10x plus 12. Okay, so it says write the expression for our third example of 2 plus x and 2x plus 6 in expanded form using our FOIL method. Well, this looks oddly familiar from the last slide before, but we're using a different method. So we have the FOIL method. So as you can see, I just rewrote the problem here, but I wanted to show you how we're breaking this down. So we're going to take this first term, and I know I rewrote it, but just bear with me. I have a 2x times a 2, which is going to give me my 4x right here, okay? So I'm going to try and color code this. So when I did my first two terms in purple, I got this result right here, which was our 4x. And when I go back to do our next step, so I'm going to take this 2x and multiply it by our x. So now we're doing our outermost terms. So that's where this 2x squared is coming from when we perform that yellow step. So now we want to do our inners. So we have this 6 times 2, which is that's where we're getting this 12 from, okay? And then our last step is our last term. So we're taking that 6 again and we're applying it to the x. So that's where that 6x is coming from. So now once we have all of our terms, we should have 4 terms total, we want to rearrange and combine like terms. So we have a 4x and a 6x, which is going to give us our 12x, which is good. We have that. We put our 2x squared out front since 2x squared has the highest power of 2, so that's going to stay out front. And then our constant 12 just is pulled down and tacked on to the bottom. So we have 2x squared plus 10x plus 12, and if you go back and double check with the same problem we have, 2x squared plus 10x plus 12. So I just wanted to bring to your attention that we can solve this problem both ways, and you've seen that in class. I just wanted to double check, so this is almost like our check method. Okay, so our next problem is factor the expression x squared plus 4x minus 32. So when we're factoring, what we are looking for is we're looking for our two binomials. So we have one binomial here and one binomial here. But the trick is we want to look at this negative 32 as almost being our area, and we want to look at this 4x as almost being half of our perimeter. So if it helps you to remember those problems that we're doing when we were trying to find the two dimensions, the length and the width, that would give us an area of 32 but a perimeter of 4. If that helps you, then stick with that. But let's go ahead and see if we can solve this. What we want to start looking for are factors of 32 that might add up and give us a positive 4x. So if you guys were able to work this out on your own, you should have seen that 8 and 4 are going to give us our match for this. So we have our pair in 32, our factors of 32 are going to be 8 and 4. So now we have our factors, but now we have to pay attention to this negative sign out front. So it's a negative 32, which that indicates to us that either this 8 or this 4 is going to be a negative. But we need to choose wisely because we have this positive 4 out front. So what we want to do is we want to realize that when we add a negative 4 to a positive 8, we're going to get a positive 4 left over when we combine our like terms. So that's how we knew where our signs were coming in together. So now, yay, we were able to figure out what our factors were in our binomials. So let's go ahead and check. So when I FOIL this, I get x squared down here, and then I get negative 4x. When I do it again, I'm going to get an 8x here, and then when I do my last step, I'm going to get a negative 32. So when I combine like terms, my final answer is going to be x squared plus 4x minus 32. Moving on to the next one, we're going to use the FOIL method to write the following binomials in expanded form. So basically what we're doing is we're using the FOIL method. So if you go ahead and look, I did the FOIL method for us, but we have an x squared, which is our first step, which are our first terms. Our outer terms are going to give us a positive 6x, our inner terms are going to give us a negative 8x, and our last terms will give us a negative 48. So once we combine our like terms, our final answer is going to be it's going to be x squared minus 2x minus 48 as our final answer. Going along with that same idea, we're going to be using the FOIL method. So if you want to look at my work right here, when I did the FOIL method, and I tried to keep things color-coded so that you guys could see where they're coming from, but with my first step I got 2n squared because we took the 2n times the end, and then for my second step I had 2n times negative 3, which went to a negative 6n, and then for my inner terms I had positive 4n times n, so I had 4n right here. And then for our last terms, we had 4 times negative 3, which gave us a negative 12. So when we combined our like terms, our final answer is going to be 2n squared minus 2n minus 12. So hopefully you guys are pausing the video and double checking to see if you're able to do this on your own. Okay, so this is our last FOIL problem. So if you go ahead and solve this on your own, you can follow along with my color coding, but here's what our answer is going to be when we FOIL. If you follow the green, that indicates our first terms, so we have a 3p squared. And then our blue term indicates our outermost terms, which will give us a negative 15p because we have a 3p times a negative 5. And then if you want to follow that purple step, I'm doing our inner terms, a positive 7 times a p, which will give us 7p. And then our last step, which was my yellow, which is our last terms, I have a 7 and a negative 5, so that gave me my negative 35. So then go ahead and combine your like terms like we have been, and you should get 3p squared minus 8p minus 35. So hopefully you guys are trying to practice this on your own. You should see that it's not too bad once you do a couple of these. So going to our next problem, now we're factoring. So now we're working the opposite direction. And this was what a lot of investigation 2 was involved with. So if we're looking at this, like I said before, we're trying to find those binomials that are going to multiply and give us a 6, but add together and get us a negative, or add together and get us a positive 5. Excuse me. So we're trying to find a positive 5, but multiplying to get a positive 6. So when I went through, I thought that this was a pretty simple one, but it's going to give us 2 and 3. So we know that 2 times 3 is going to give us 6, but 2 plus 3 is going to give us 5. So I was able to get that one really quickly. Hopefully you guys were able to catch it quickly, but Then I wanted to just go ahead and show you that this check step isn't necessary, but I highly encourage it if you're not sure. So say I wasn't sure, I wrote out my binomials that I factored, and then I started to FOIL. So I got an x squared plus 3x plus 2x plus 6 when I did our FOIL method. And then when I simplified for like terms, my 3x and my 2x turned into a 5x plus 6. So then if you can see, this is our original equation, so it got a check mark and I'm good. So I know that I chose the right factors and I know that I'm correct. So it's kind of a foolproof system if you're able to go back and check yourself. Okay, so now we have d squared minus 36. So there should be like a lot of red flags going up because we don't have a trinomial right now. We only have a binomial since we only have two terms. So that should be kind of like a red flag. But we want to look at this and see what our numbers mean. So we have a d squared and we have a negative 36. So we should know from our perfect squares in our last unit that 36 is a perfect square. So we have a square and we have a perfect square, which is d squared. So this is the difference of this is the difference of squares. So this is one of the vocab words that we'd studied throughout the unit, and this automatically factors to something really pretty, and we should know off the top of our head. So when we see the difference of two squares, we should automatically know what this factors into. So we're going to get d plus 6 and d minus 6. And the reason that that happens is because when we go back to double check our work, but we should know that we're right. When we go back to double check our work, we're going to see that this FOILs out to be d squared minus 6d plus 6d minus 36. But our negative 6d and our positive 6d are opposites, so these two are going to cancel out, and that's why we're left with our d squared minus 36. I apologize for that being a little covered up at the bottom, but what we should have is this should all work out, and we have a check, so this will give us back to it, our d squared minus 36. So right here are our factors for this one, so this is our answer, d plus 6 and d minus 6. So this is the last solo factor problem, and then we have one challenge problem together. So we have d squared, or n squared minus n minus 56. So like again, like we've been doing, we want to find the two binomials that are going to factor this expression right here. So we have a trinomial, and what we want to do and what we want to start with is what two factors will give us 56. So off the top of my head, without even really thinking and putting too much effort in, I know it's 7 and 8 are going to be my factors. And that kind of gives me some hope, because what's the difference between 7 and 8? And we know that that's just 1. So if we look at our coefficient out in front of our second term, we know that it's a 1. I mean, granted, it's a negative 1, but we know it's a 1. So right away, this should kind of push you in the right direction and know that you're on the right track. So I did choose the 8 and 7 to see if maybe I could fool around with those and see if I could get it to work. And like I said, we have a negative 1 up here. So if I let 8 be a negative 8 and I add negative 8 and positive 7 together, that's where I'm getting my negative 1 from. So that's why it's important for me to remember that I can manipulate this answer by changing the signs. So since we know it's a negative 56, one of these two factors needs to be negative. And then we know which factor it has to be when we look at our second term, because then we can kind of see which one is going to give us a greater answer or a smaller answer. So like I have been doing for the other ones, the check step is not necessary, but like I said, if you're not sure that you got the right answer, go back and check your work. So I went back and checked, and I got n squared plus 7n minus 8n minus 56 when I did FOIL. So I'm trying to lean away from showing you the FOIL step, so you guys should be able to do that on your own. But when I went back and when I simplified and added my like terms, I got n squared minus n minus 56. So that's where that's coming from. And so for our last problem, what I'm working with is we're doing a challenge problem. So this is one that is kind of similar to the one we did on investigation 2.3. So what I wanted you guys to do was, what did we talk about in class? We talked about what do we know. If you don't know where to start from here, that's perfectly fine, but let's at least at the very, very bare minimum, let's draw our parentheses, okay? So we have our parentheses down, and you still might have no idea where to go from here. But what do we know? We know that the only two possible factors for this first term, 2b squared, have to be 2b and b. So we know that for sure. There's nothing else that will factor into those. Those are the two factors. So then I know that the negative 17 really throws people off. So sometimes that's a challenge. But we see that this is a positive 21. So we know it's a positive 21. So we know that they're either both have to be positive numbers to give us a positive 21, or they both have to be negative numbers. So a negative times a negative will give us a positive. So either both have to be negative or they both have to be positive. So those are our options. So now what we want to do are look for factors of 21. Right here. So now we want to look at factors of 21. For right now, ignore the 17. Just pay close attention to this sign right here. So since this is a negative, we know that they're both going to have to be negative since we can't have two positives. So we can actually erase those. So we know that we're going to have two negative numbers, and at this point we can write those down. So we have a 2b minus and a b minus. So now we have, I know it doesn't look like much, but we have way more than we thought that we would ever get. So let's go back to this 21. Let's find our factors. Our only factors of 21 are 7 and 3. So now what we want to do is, we know that it's 7 or 3. So a 7 could go here, or a 7 could go here, the 3 could go here, the 3 could go here. So if you guys can't see right away what order it would go in, solve one. So let's say, for instance, we're going to choose and put the 7 with the 2b. So by default, our 3 would go here. So let's go through and solve and see if we get the right answer. So let's check ourselves. We have 2b and 2b times b, which will give us our 2b squared, and that checks out with our first term up here, so we're okay. Now let's do our second step. We get our 2b times our 3, our negative 3, so we'll get negative 6b. And then we're going to go back through and we're going to see that this is negative 7b. And then we're going to get a positive 21 when we go back through to solve. Okay? So now we want to combine our like terms. So a negative 6 and a negative 7, we're going to give us a negative 13b plus 21. And then we have our 2b squared out front still. So as you can see, this does not equal our original equation up here. So this does not give us our original equation. So by default, we should realize that this order that we chose, the 7 and the 3, are wrong. So we should switch. We should switch those. So let's go ahead and switch those right now, and let's rewrite the problem and double check. So we have a 2b minus 3 this time, and a b minus 7. So let's go through one more time just to double check. I mean, if you can realize at this point that you would just switch these, great. But if you still need to prove to yourself why this worked, let's go back through. So we have 2b times b, which will give us our 2b squared. And then we have 2b times 7, which will give us a negative 7. Nope. Hang on. I made a mistake. We have our 2b times our negative 7, which will give us a negative 14b. My apologies. It's negative 14b. And then we'll have a negative 3 times b, which will give us our negative 3b, and then we're getting our positive 21. So now when you look at this, you should hopefully see that when we combine our like terms, our final answer is going to be 2b squared minus 17b plus our positive 21. So this checks out, and we should see that. So if, like I said, if you guys have no idea where to start for these problems, start with what we know. Break down the problem and focus solely on the first term and the last term. And the only thing you really need to focus on in this trinomial is that term right in front of the second term. So right in front of the 17 is that negative sign. And that negative sign told us whether we were going to have two positive numbers or two negative numbers. So that sign in front of that term is very important. So keep that in mind. If you guys feel like you still need more help, you know that I'm available at the BOT program after school, and I know the BOT program might not be something you'd ever consider, but it would be more of one-on-one tutoring with you, and that's what I can provide. So if you don't have any time during your if you don't have any study halls during periods 9 or 10, I'm available after school. You just got to let me know that you're coming so that I can set aside time and meet you in the cafeteria. And I'm also available during home base in the morning and afternoon home base during resource time. And like I said, I'm available for periods 9 and 10. I can meet you in the library. Just let me know and I can meet you there.